How are line equations used in computer graphics? Imagine drawing a straight line on your computer screen that looks smooth and perfect. How does the computer know exactly where to place each pixel to make that happen? That's where line equations come into play. When you see a line in a digital image or a video game, it's not just a simple connection between 2 points. It's a precise calculation based on mathematical formulas that tell the computer how to draw that line pixel by pixel. In the world of computer graphics, lines are described using equations like the slope-intercept form, which is written as y equals m times x plus b here. Y and r are the coordinates on the screen, m is the slope, and b is where the line crosses the y-axis. This equation helps the computer figure out what y value to use for each x value along the line. Another way to describe lines is through parametric equations, which use a parameter called t that varies from 0 to 1. This method is useful for drawing line segments between 2 points because it calculates all the intermediate points along the way. Since screens are made up of tiny squares called pixels, the challenge is to convert these smooth, continuous lines into a series of pixels that look like a straight line. Algorithms like the digital differential analyzer use the line equation to find the best pixels to turn on. For example, if you want to draw a line from the point 2 to the point 6, 6, the algorithm calculates the pixels at 3, 3, 4, 4, and 5, 5. These pixels from the visual line you see on the screen. The screen's coordinate system starts at the top left corner, with x increasing to the right and y increasing downward. There are also more advanced algorithms like Bresenham's line algorithm, which is faster because it uses only addition and subtraction instead of multiplication. This makes it perfect for real-time graphics, like in video games, where speed is essential. These algorithms help the computer decide which pixel to light up next, creating a smooth and accurate line without wasting processing power. Line equations are also vital beyond just drawing lines. They help from the edges of shapes like triangles and polygons, which are the building blocks of more complex images. In three-dimensional graphics, lines and shapes are manipulated using vectors and matrices. When you rotate or scale an object, the computer applies matrix operations to change the coordinates of the points and lines that make up the shape. This allows for dynamic scenes where objects move, grow, or shrink smoothly. In summary, line equations are the foundation of how computers create and manipulate images. They help calculate the exact pixels needed to draw lines from the edges of shapes and enable transformations in both 2 and 3 dimensions. Without these equations, digital images and animations wouldn't be possible. They turn the continuous world of geometry into a grid of pixels that our eyes can interpret as smooth, connected shapes and figures.